In this equation, in this lesson, we are looking at simultaneous equation using determinant method. The determinant method of solving simultaneous equation. And today we are looking at two equations in two unknown. Two equations in two unknown using these examples. So now, how do you solve this simultaneous equation using determinant method? First, make this coefficient of the unknown as 2 by 2 matrix. How do I mean? You have the coefficient of x here is 6, coefficient of y is 11, coefficient of x here is 1, coefficient of y here is 2. Make them matrix. And the unknown that you are looking for, x and y, should be equal to the answer, which is 29 and 5. If you have done it, then find the determinant of the matrix itself, original matrix. Write that. That's determinant of the matrix, which will be this multiplied by this, that's 12, minus this multiplied by this, that's 11. 12 divided by 11 is what? 1. Now the determinant of the matrix is 1. Then find determinant of x. How do you find determinant of x? Write that x. Then replace the coefficient of x. Don't forget that this is the coefficient of x. Replace this coefficient of x with this answer. Then retain this one. Replace this one with this, retain this one. How do I mean? This place will now be 29, 5, which I will replace the coefficient of x now with this value. Then I will retain this one. That's 11, 2. So my det x should now be equal to this multiplied by this now. So 29 multiplied by 2, that will give me 58 minus 5 times 11, that is 55. So if I subtract this from this, my det x is 3. Do the same thing for y. Then in this case you have det y should now be equal to, now retain the value of this x. So to the answer for this one, you retain this one. So you have 6, 1. Then instead of writing the coefficient of x now, write the value of the answer, which will be 29, 5. Then find your determinant. So my det y now will now be equal to this multiplied by this 5, 6 multiplied by 5, that's 30, minus 29 times 1, that's 29. So if I subtract now, my det y will be equal to 1. So to find the value of my x and y, now say therefore x is now equal to det x over determinant. So x will be equal to what? Det x, determinant of x, that's 3, over the general determinant, which is 1. So therefore my x will be equal to 3. Then for the y will be equal to det y over det determinant. Then my y will be equal to, what det y is 1. My determinant, original determinant is also what? 1. So 1 over 1 is 1. So therefore our x is 3, our y is 1. So this is how you use determinant to solve simultaneous equation. Two equations in two unknown. So this is the example of simultaneous equation using determinant method. Two equations in two unknown. Let's solve this second example also. So I'll first make the determinant, the equation determinant first, like this. So the coefficient of x here is 1, coefficient of y is 3. Coefficient of x here is 2, coefficient of y is 4. Then it should be equal to my x, value of x and y. Then it should be equal to 2 and 1. 2 and minus 1, the answer. So I'll first find my determinant. So the original determinant will be this time, this, that's 4, minus 3 times 2, that's minus 6. So that will give me 4 plus 6, that's 10. Then I will now find det x. So I will replace this one with this answer. That will give me 2 minus 1. Then I will retain this one. minus 3, 4. So my depth x will be equal to this times this, that's 8, minus 1 times this, that will give me plus 3, that's 3. So 8 minus 3 is 5. Then I'll find my depth y also. So my depth y will be equal to, now I will